Hi, this is Mr. Miller, and in this video, we're going to talk about infinite intervals. Okay, let's get started here. So, our first step in this video is to do just a little bit of review. These are finite intervals that I graphed here. They're bounded. They don't go on forever. In fact, this first graph here are numbers that are between -3 and 1, and not including -3 and 1. It's finite. It's bounded. There are limits to this graph. Okay, well, we have already learned how to write an inequality for this. It's kind of a combination of two inequalities. So we're going to say these are values of x that are greater than -3, and at the same time, they are less than 1. Okay, both are true. These numbers here in this interval are larger than -3 and smaller than 1. They're in between those two values. Okay, well, in interval notation, it's kind of like a shorthand for writing this. We're kind of just writing the endpoints of the interval. An interval is just a range of values. So this interval starts at -3 and ends at 1. So we're just going to write -3 and 1. And we're going to use curved parentheses around it. So this means the interval numbers, the range of numbers that start at -3 and end at 1. All right, so just a little reminder, if it's a hollow dot, that goes with a curved parenthesis. In the second graph, we have a solid dot here that we're going to see that goes with a square bracket. Let's start with the inequality first. We have numbers that are greater than or equal to 2, so I'll write that like this, but less than 9. Okay, so the endpoints of this range of values are 2 and 9. So I'm going to write 2 and 9. On the left, we're going to put a square bracket, like I said, because that means that includes 2. And on the right, we're going to put a curved parentheses because it doesn't include 9. All right, so this means every number in between 2 and 9, including 2, but not 9. All right, well, it's time for infinite intervals. These are intervals or ranges of numbers that kind of continue on forever. Like in this first graph, it starts at 5 and continues to the right forever. That's what this arrow means. It keeps going. We've already seen how to do this inequality. This is x is greater than or equal to 5. So that part is not new. What's new is how we express this in the interval notation. Well, we're going to use a square bracket and 5 because that's the lower endpoint and it includes 5. Then, since it goes on forever, we're going to put an infinity symbol here. And we'll always use a curved parentheses with infinity. This means I have numbers that begin at 5 and include 5 and go on forever. They go to infinity. Now, infinity is not a number. That's why we can't include it. And so we never use square brackets with infinity. It just means it goes on forever. So curved parentheses with plus or minus infinity. All right, the inequality for this one is x is less than 9. Okay, so this one kind of begins at negative infinity. It comes up from all the way over to the left. So we're going to put curved parenthesis and negative infinity, and then the right endpoint is 9, and a curved parenthesis because it doesn't include 9. So this means all numbers from negative infinity to 9. Okay, so that's not too bad. So infinite intervals aren't really that bad. We just have to be careful with the infinity symbol. All right, this one would be x is less than or equal to 1. We think it comes from negative infinity. Where does it start? It comes from negative infinity and ends at 1. So an interval notation is going to be negative infinity to 1, like that. All right, this one. Numbers to the right of -2, so this is going to be x is greater than -2. So this interval starts at -2 and goes on to infinity. So we're going to write it as -2, infinity, like that. All right, this is our last example here. So we want to complete the table. Okay, so we have x is less than 9. So a hollow dot at 9 and an arrow to the left. That helps me. The graph helps me write the interval notation. I see it comes from negative infinity. And it ends at 9. So that's interval notation. X is greater than or equal to 6. Well, solid dot at 6. Arrow to the right. This interval starts at 6 and it goes to infinity. Okay, here we have a graph. Solid dot at 10 and it goes to the left. So this is x is less than or equal to 10. And it starts at negative infinity. Goes up to 10 and includes 10. So square bracket like that. All right, last one, we're given interval notation. Well, this interval starts at 14 and goes to infinity. So hollow that at 14. There's a curved parenthesis. And it goes to the right. Well, we know how to write this one. This is x is greater than 14. Okay, it's a bunch of examples. If you understand kind of finite intervals, infinite intervals, they're not hard at all. Good luck.